Welcome back, everyone. I want to point out that Chad had a good question here in the chat. And I'll just leave you the question. He says, a good thought question is what a floating helium balloon does inside a closed car or a train that is accelerating or decelerating, so its velocity is changing. So you're in, once again, you're in a train and its velocity is changing. What does a balloon that floats, a floating balloon, do in that case? And I'll just leave it there. It is a good thought question.
Drudge dishes, Drodica Sena, any Getirwa, any Nasuga Mincoin and Decore, any Loncoin and Decore, the Cholokanza Timshaju, the Minkurgi Korgam chicken on Laya, any Nasuga Gampu non Laya, Helium Lucia Juga Gamput in a logio by Nas, right? Helium Lucia Juga Gamput in a logio by Na. Helium Lucia Juga Gamputi Katina ko Panalayan Koperdegyorwa. Get any dinner dojo by na Delayata, Minkor data, Minkor Korgam delaya, Nurnon Diana, Nutritype pickups, and the Gampu de la Carichungi Nasi Drudge Pashas, Joy Abudos, the little Shagins.
The other thing I'll mention is that for simplicity, in order to introduce all these ideas, I've only talked about motion in a straight line. Accelerated motion in general, but always motion in a straight line. I haven't talked about, and you know, forces are applied in one direction. I haven't talked about forces that may be applied in a different direction to the direction which the object is moving. So let me talk a little bit about that now, and you'll hear more about these things later on. So,
Mibu Chica Kala shoe popa in Bayraya, shoe the Yanchi shoe Karsugeta. Mibu de Ganlaya, Kugan, you don't swing the condition on Saga Shola, shoe popa, shoot the Kasho, Chila Popa Mato, Yante the Shijayo Maris. The Tanda in Baina, Karidesha Jagin Sena, Mibu de Takum, Gucho, Tansagi Shola, the Shuch Pogo or Watina Shingi, Ningucho, some Main Baggy, Nicholaya, shoe poppy, Nitantin the Kachimutuchins.
So let me bring a few things together here. When we talk about velocity, remember we're talking about two things. We're talking about the direction in which something is moving, and we're talking about the speed. How fast is it moving? So when we talk about acceleration, which is a change in velocity, it can mean either a change in speed, speeding up, slowing down, or a change in direction as well. And because any force that I apply to an object is in the same direction as the resulting acceleration, so the effect of the force is, again, to either change the speed or change the direction, or both.
Tanda nga suge shuchi la teni de tingi buchi la nyono la jiro chimba ina kuge shuti ka kasho te nyono kasho che wa tene kuge ta nyutsela njiran ru sistem bala ya njiran ru ya te yang kuge jokse gi njiran ru nan dikore tina shen kasho la njiran ru nan dikore.
So let's say that this is the object, it's moving in that direction.
Ta gi la pa gi ngi po de wa ane ko dalo la ya guchu tambi wan ta na.
And I apply a force on it in this perpendicular direction.
Ta te ga la ya ngi tu sta ko tang chang ngo ne shuchi de na do po wa chi gi yes.
At this time, there is no force either forwards or backwards, so the speed of the object will not change.
You said there's no force.
There's no force either forwards or backwards, just sideways, so the speed of the object will not change.
Ta tanda de kapsuro ngi bo ko la ya shu de ta den tang ja la ya po pe ge shu me za ani ko ge jokselan jiran du ma res.
The direction of the object will change.
Ta ko karilan jiran du res na ko khasulan jiran du res.
So that's how you change the direction of an object. You apply a force that is perpendicular to the velocity.
Ta tanda gi ko ge ngi bo den go sho tang sa ge jokse ge khashu la ya ro jokse ge khashu la ya ne tang chang ge gon de shu chu table la tene de nga chu ngi bo de ge josa ge khashu la jor tang ge res.
So, for example, in circular motion, when something is going around in a circle,
ta ngi bo chi ge ne ko column se gura ta gorgor ge lam la ya de chi ya ge tina do pe chen chi yo pa na.
It can be going around in a circle with constant speed, with the same speed all the time.
Ta ko lam ka te gorgor chi na du de
Applying a force all the time towards the center of the circle.
Ta te yong ya la choran kar chi go res na te ya shu chi ka tu ma na te go res ta shu ti kar res na ta ko ge ko go chu tang sa gi te wa chi go ro ta te wa te la ya kha sho be shu chi ka tu na teng go res.
Yeah. So, like I said, you will hear more about this later on, but I just thought I would mention that.
De ko te che chu ge je la ya ne chi ta ji bo che chu la mu to ji res.
Yeah, I think I'll leave it at that. Okay, so I did mention that there were three laws of motion according to Newton, and we still have to talk about Newton's third law. So let me share my screen.
Da nga su ge Newton la ya Newton ge tension sen yo pe ko mo pe chi sha ge sta ta nga so tha de te ne mo Newton ge tension sen ba de sha ge.
So I think I've already mentioned Newton's third law. So take, for example, the situation that we've been talking about a lot, which is simply that a ball is in free fall and it's pulled downwards by the force of gravity, which the Earth is applying on the ball.
Da nga su ge Newton ge tension sen ba ko la nga su ge chu sing de shi je yo res ta da de ka se ba na ke de nga su ko pu lu chi ro ta rang hong chi rang wong ga ne hong pe chi ba na rang ho chi chu pa ba na de kap se su ko la ge ten shu ke ne pu lu te ma thang ge yo res.
It may seem surprising, but this is also true. And if you think about it, it has to be true. That the ball is also pulling on the earth.
다 현대 지가리오레스나 다지 뉘에 임바 지가리오레스나 볼로 되게 양 스콜라 볼로고 쇼스야 탱기오레스.
It's pulling on the earth towards the ball, so it's pulling the earth upwards, and the force that it's applying is exactly the same strength.
볼로 되게 스콜라 때 볼로고 쇼스야 탱기요 바타 아니 거기 볼로 되게 스콜라가 야 탱기 슈테야 스콜라기 볼로데 마템비 시당 지바치게 탱기오레스.
Of course, it's the soccer ball and the elephant all over again. The force, the strength of the force of the ball on the earth may be the same, but because the mass of the earth is so much bigger, the actual acceleration of the earth is much, much smaller.
당가 주고 볼로 당 저 랑친라 무작당하게 비탄 손에 단단히 값으로와 아니 그 슈퍼다 슈퍼 포고였다 임바이나야 스콜라게 되세티 볼로가 되세리 하장다 전부 예장 아니 볼로라 포베기 뉴런 치와당 스콜라라 포베기 뉴런 하장 좋아요레스.
So this is a general rule. When two objects interact, and it's always the case that you have an interaction between two things. When two things interact, they apply forces on each other, and the strength of the forces is exactly the same, but they are in opposite directions. And this is Newton's third law.
다 가지고 용체가 팀가르에서나 게팅 이번이가 반슬라에 대주치고 요바이나 대니가게 아니 반슬라 슈동 그레스 슈기 제종 직바지 가쇼 도바진동 그레스 데라 가르치스 그레스나 뉴턴 같은 팀 심바스 그레스.
It makes sense, although it may be surprising, but it makes sense because if you have the ball being pulled by the earth, why would the earth be the only thing that has the ability to do that? Any mass should have the ability to do
that. You were cut off at the beginning. Can you repeat it again? Sorry.
So if you think again of a ball falling towards the earth, because the earth is pulling on the ball, why would the earth be the only one that can do that?
That 단단히 값으로 가서 볼로지 스콜라 가한테 사바테 가라 산노 당바인바이나 아니 가서 그래다 지마 대니티 스콜라 지고 있는 거 준생 가르치네래 사바이나.
Right. So that's Newton's third law, and let's look at some other examples of this. And we're now in a position to use all of Newton's laws to reason about a situation. So here's a very simple example. You have the apple here sitting on a table. So I look at this and I think, okay, so let's look at the apple. The apple is not moving, therefore it's not accelerating. And I'm going to assume that Newton's first law applies here, so that I'm in a not accelerating reference frame. So my conclusion here has to be that there's no net force acting on the apple.
아니 되게 강라야 부시 강라야 아니 장수주 폭매발라야 방문지기yes.
Now, there is no net force, but I do know of one force that is acting on the apple, which is the Earth gravitational pull.
That another cause Sangshuchi Pokoyo Maris, Imena Yang as we shenda, Tigalaya, Shuchu Pokoyo Pangasu Nigioris, Karipoyorena, Sukola Tenshu, Kushuti Kushosuma Tangioris.
So I have to conclude that if there is no net force acting on the apple, but there is a downward force, there has to be another upward force to cancel the effect of gravity.
That de la Tenetangari, Karichin them Chiguyores, and Sukola Tenshuku Kuma Tangioris, Imbana Kulaya Sangshuchu Meba Inza. That Sukola Tenshu de Kota members was or a Chanyum Zuage Shuchi, and a Kayate de Yupate, and then Arange Kasura. That's so much grace.
Yeah. So I've used Newton's second law to discover that there has to be an upward force on the apple.
Then you don't continue like the takers and a sukul Dadagi Karsa Kushudi Galaya, Kaya Shopik Shuchu Patian, Haku Yores.
And the only thing that can be applying an upward force on the apple is the table.
Tandade Caps any Kaya Shopik Shuchu Kushugalaya, they can Kunachi your particular and they caps Chositiris.
So this is a bit surprising. How can the table be pushing up on the apple? The apple is not going upwards.
That the Yansemburis, Kajila by na Kushiti Kuya Drugum was, in by Nayan Kola, Kushiti Kuyala, Yashuchi Tegi was.
So the answer is, although it's a little bit surprising, I guess, that there is an upward push by the table. It's just compensated exactly by the downward pull of gravity.
Tanda Droxiti Kushiti, ya Dobby Shuchi or Degi da Karchigores and Sukula Tenshute Danko Chanyam Tatazuris.
Now, Newton's third law says, okay, if the table is pushing up on the apple, that means that the apple is pushing down on the table.
That Newton tension Sumba Karsugurs and a getty and a toxicity Kushute la ya, and Shuchu Tanguyo Pina. And it could shoot again, toxic down la Maya, shooting Donguyores.
And that is correct. In fact, if I put an elephant there instead of the apple, the elephant would probably break the table.
Can you repeat the last part? Because
if I put an elephant on top of the table instead of the apple, the elephant would probably break the table.
The getting at Kushiti Sablaya, launching Chishaba in Bana, launching the Peshe Doxity chocolates.
Yeah, so in general, this is how equilibrium, which means that there is no net force acting on something. This is generally how equilibrium works. If there's no net force on an object, but I know of at least one force that is acting on the object, then there must be another force to compensate.
Tangatsuki Chanyam says or a Chanyam Gadanshindi Kapsimbana, Ko Gangala, Sanshuchi Pokome Pati Kuguris, the Kaps Niketi, Mubuchiki Karsgreta. Gangla ya shuchu puyo paina tila tene de tangi kari hakures na chanyam gi nebaring bana ma ko shuchu yo bana ya kayate pe shuchu yo payangang hakures.
So yeah, in this case, it's the table that's pushing up on the apple with exactly the same strength force, but in the opposite direction.
Tanda de kapsi bana ko drosete gi shuchu tagureka wa Shuki Chechonte Kushuma Nembata Chipache, and a Koga Kashote Tige don't shooting Doshores.
Yeah. Here's another one, and this is an important example because it is the way every form of locomotion works.
다 드나 비선 지스틱 비선 개 전부차가 요스다 딩아 속에 네 지금이 네 젠다실라 드야기 지금 네포지야기 안고초 지거와 고초 띠기 갑라야 디기 니츠디게 전부차가 요레스.
So when we are running or walking, for example, the way we propel ourselves forward is indirect.
Can you repeat the last part?
Yeah. The way we manage to accelerate forwards is indirect. It's not. It's not direct.
당가수 가서 그래. 공부자가 죽셔 램비 값은 아주 단로가 줘야 지거와. 때 가서 그래다. 때 중요야 때 카케 중요요 말이스다. 카툴리 도쇼스 인다이렉트는 가서 그래다. 쇼니 중요요레서 부도가 어떤데 지레스.
You cannot apply a force to yourself.
한때 쇼니 중고르게 진선대가라는 초론 단노가 줘야 가서 초론가 강라야 슈치가 더해요 말이 그 말이스.
So how does this work? So your shoe at any moment is pushing back on the ground.
단단데 값에 쇼니 중고서 태클 많이 군이 중고레스. 단단데 값에 아니 초론 게 슈치 넌트메선 가르치고 그래서는 초론가 한국에 아니 사가강라야 잡로라야 비자탕 슈치 당고요레스.
Yeah, so something like that. But then the ground pushes you forward.
다초는게 한국에 저런가 강박이 아니 가서 그래 사강라야 아니 마음 비자탕 거 잡로라 비자탕 거 요청 니 사기 저런 단로라야 비자탕 거 요레스.
So your shoe and the ground are interacting with each other and they apply forces on each other that are equally strong and in opposing directions.
다단데 저런가 가서 그래다 강박이 사강라야 비자탕으로 마음이 잡로 비자탕 담바 사기 저런게 강박이 비자탕 그래서 대갑서 네 슈데 인샤 가리요레스나 슈데 인샤게 최종 총바제 주바제 에네 가쇼도 되요레스.
So it's not that I am pushing myself forward, it's the ground that's pushing me forward.
근데 값을 가르치는 나랑 단로라에 비자탕 거 옆에 그 말이스. 다 스쿨하게 아니 사기 간파용으로 그 사기 나는 단로 비자탕 거 요레스.
The shoe sticks to the ground and cannot slide.
단단데 값은 아주게 함께 사기 강라야 딱갈수 그래. 사기 강라 저선 사강에 그 데더쇼고요 말이스.
Here where I live in the winter, we very often have ice on the ground. And if it gets warm during the day, the top of the ice melts and then it freezes again at night and it's very, very smooth.
단단가 대사기 사치데라야 공카인 바나 카와 강잡지 차바차그레스와 아니 니마 셔비 값스 아니 강기 따치 강다 차바데 쉬거와 아니 산다고 양치 차바차그레스다티 차바차바데 아니 고커스고다 데데슈 타우슈 슈인 잠부차그레스.
So very often, if I try to walk on the ice, I won't be able to do it because my shoe will not push against the ice and it will just slide backwards, and therefore the ice will not push on my foot.
다티 값은 바나 차바데 강라야 아니 nga kampa japaina komba jat kamaris kachla paina ngi hamguge ani chapa gangla ya ko kaso ta kuchi tugu gura tuchi de tan de masho gane 아니 잡아대 마음 비자던 데다 잡아가 양 비자던 거로 뒤에 짓고요 말이지 가도 바이나야 같이 그래서나 잡아가는 데데쇼데디 아니 그 감바자 카푸지 그랬어.
Walking and running are only possible because the ground is pushing us.
아하. 아니 나츠 감바자에 죽샬래야 티고 종트 요바티게 진진 코나티가 데서나 나츠 마라코 사가라 베자탄 왔더니 사가 나츠 달롱 베자탄 거로 어디라테네 데탄 나츠 감바자에 죽샬래야 티용 거레스.
Same thing happens with a car. Again, notice the wheels of the car are touching the ground.
다티 나지 치바치치가 미 랑콜라야 중고요 레스타다 데네 고 랑콜고 콜로티 살라 투데요.
So the wheels turn, pushing the ground backwards.
다 콜로티 코르데데 고 사데 잡로라임 자탄기요 레스.
And then the ground, in return, pushes the car forwards.
다 데게 고 야란타올라야 쑥 사게 아니 랑콜기 콜로티 달로 자탄기요 레스.
Again, it's an interaction, this time between the wheels and the ground.
야체 디 값인 바네 가수 데저 세티 모인 거 레스 데저 티가 레스나 랑콜기 콜로다 사게 바르라 데저 레스.
And then according to Newton's third law, those two forces are equally strong and opposite to each other.
다 뉴턴 같은 텐션 바터바이나 데라야 슈차니 도가 슈차테 니셴 바나 고게 지점 성바다 안에 가셔도 돼요.
Mhm. I control the force by control the engine. Sorry, the engine controls the force by controlling the rate at which the wheels turn.
랑콜게 그런 거 듣지 않아요. 랑콜 그런 거 듣지 않아 되게 아니 그 가서 그래. 콜루게 콜세치고로 텔라 당진 집이 가네 아니 그다 지금 달로가 드비기 슈트텔라 tan지지고 그래서.
Yeah. So in locomotion, in moving either ourselves physically or in a vehicle, it's always the same. We're always pushing against something, and then that something pushes back on us.
다 데네도 게디팅네 디젠다치라 포야기 디지데다고 임바이나 가수 컴파자도 타 랑콘달로 드wen도 티바이나 네 토마데 로 스콜라 잘올람 베자타니 숙사기 가수 잘올람 베자타나 테니 루요레스.
Yeah. Another example of a force is one that's been mentioned a little bit before, which is friction. And the characteristic of friction forces can be, for example, a force is sliding friction between two surfaces, and that's what the shoe and the ground are about. Or it can be friction because you're moving through the air or you're moving through water, let's say.
슈티 젠다 슈키 베춘치카리오레스나 더슈그레스 더슈딩 아수게 데시 this chapter is that another capsule 더슈세티 뉴고니 트래픽 값이 좀 이슈지레스 that 임베치네 가서 감바잡리 값 함다 나서 감바다 산이가 바로게 다시다 양나 현대진 가서 지금 드비 값 맞추게 스포데다 아니 롱가나는도나 감바잡리 값이 만나 롱게게 어떤 디디가 바로게 가서 데줄라탄 바타야나 가서 추근하는 드비 값이 추근디들 라탄 데줄라탄 데탄 좀비게 슈티 라 데슈스기레스.
The characteristic of friction forces like this, when you're moving through the air, also called drag forces, the characteristic is that The force is always opposite to the direction in which you're going. The force is always opposite to your velocity.
tanda diratogi ani darshitela ya matsugi dreshus na just dreshus sege dreshus grau that tanda delana ditura amna that dreshus sege reswa tikar sana dinato wishuti kati imbaina ya ngatsun dreshichia ge khashole dogle ani korange shooting dong res.
So in this case, the runner is running to the right, so the air drag force is to the left.
Tanda de kapsen bana jushalani te ko yeshola ya jushalan gwa destabala ya ko gala popigin dushu sena yana dushu that touch to the dushu tanga yana dege darshute ane ko ge jablola ya popioris.
If he turned around and ran the other way, the friction force would be towards the right.
Takete choran kachelo de ta sho doa de la juba imbaina yang te kapse darshite yang kachelo de ta karse choran rusa dege doshola ya ane darshute popachires.
Again, it's the same thing. The runner is pushing through the air. He's pushing the atoms of the air as he runs through the air.
Tanda ko netanya kapse na chipares tikala na ko jusha lanye de ane longin dudig nanglo ne ta ko andanola drogo wa.
So the air pushes back.
Long dudig juchi la don juchi ko andanola drogo so long ko ane jablol ma bijatan kres.
That's how a bird flies. A bird pushes down on the air with its wings, and the air pushes back up.
Tatila ten de tarwa ani ngaso chimala ta ani chagri te ko ya prech goro tin go des karchila bana ko ge shopati ma yu pala ten de te shopati ma yu de ta long te ma bijatan goro ne long shopati ya bijatan wala ten particulars.
So again, Newton's third law.
Te kapsen bana ko Newton ga tension somebody and the yes.
Friction forces or drag forces like this also generally are stronger the faster you're going.
Tatandagi darshu sa ta yana tishu sa de chiptang chani bana ka de resne keti choron katsu jonjo la ye dro ba imbaina ane ko darshu tyang titso gi yan choyo res.
So if you're moving at low speeds, it doesn't really matter too much. Drag force is very weak.
Keti choron duagin joksetil heledo imbaina ti kapsu tishu sa de shu chambo yo ma hachon chon res.
But if you're moving at a higher speed, then the drag force may become more important, stronger.
Keti choron jokse hachon tumbo gane lugo yo imbaina de kapsu tishu sa de ka shu chinti shu chwa yung res.
Yeah, so for example, runners in competitive runners who are in a race will generally wear very tight clothes so that they don't flap around and offer resistance to the air.
Da nga tso chi jukshan dendru na la ya chinye ge ju junken ku sa chambay baina ne ku su gen namjin ba na nga tulo konstan ba tulo zuku ga tel pe tambu kongyo estati jinsen karchi la baina ji tulo chlo ne yama yu chi kula ya long da ngoshi ta da shi ti mambo ma pwa ge chetrwa otigi chet zuku ga tel tulo ti tambu kongyo res.
Cars that are designed to go very fast, they usually have a shape that also reduces as much as possible the friction in the air.
Tin ang shinga nga so langkor imbaina ya langkor ge ku ge chulok ko zota ge yip chi yorwa ote ya ane longin go shoot no long der shoot long go shoot te jinyo ton ya ge chete ane ku chulok ko karsugre langkrog gi chilote tus zukuji res.
Yeah. So yeah, friction always acts in the opposite direction to the motion of the object. Okay.
Tenga tsuge darshuti ka tu imbana ya nga sugung guchuge khashota dowi mune dongres.
So those are all the examples I'm going to talk about with forces in general and all of Newton's laws. But before I go on to something else, let me ask if there are any thoughts, any comments, any questions about any of this.
Da tanda de nga tsu shitang debi ge kicha shea di tisam yins ane tanda lamsin shenda chitra yes di ma chingwe la ya yin chitsuna la George and utang samtsu shenyi yes.
겐다 nga tiwas ta ti nga zo da ki genla gi soye de kharza ani deze ji ni ngombo ni de ani khoni ani thenshu de ani ngombo ni kala yores ro an din zala pena nga zo ani sai ten do imbai na ngombo cheju ni de ani phazu them me de jara gochung mi do ta sai thenshu mesa pena banang ta bo cha sha ina an tinala ta ngombo cheju ni de tila sha ina ngombo chewa de ge chungwa de ya them ge de ni yogi na menas di yo ina ta de kharzanda khalam yora 남도 칼때 디나라야 고조 ngombo 체중대 강자야 그러 직 유디 선바 다로 그러 템보 간 로그도 못 파조야 체중이 벌라 파조 태기 들이지 미세기 통음도 어디엔서나 되고 니가라 태기 누바 열라디 아니 고아 칸디 칸라 게고 이나서 디지
Ale churung ge pisente ka shabe khalben shabe.
남도 날라 페나 도게 다 바낭갈 도게 남도 도 어디나 ngombo 충충된다 침보된다 유디 선바 다라 니가 파조 자니 도문도 파조 그러 tempo kan rogo 되세 가라 파조 되게 tempo kan rogo 파조 팅미 돌라다 조 디레다 가죠
Ale las.
팅미 도 어디 칸디나 하서디
Ale tang yubo chonchon iga paro la ya tenshu yo pa tang atsu thongko mendo station sen songsa kharwa.
어디
Allah so. His question is about gravity. You have mentioned that any two objects they exert a gravitational force on each other, and usually in our real life, like on a small object, we don't usually see the effect of the consequences of gravitational force between them. He just gave an example of like throwing two different masses in a plane or in a car, and we see that they will move forward whichever they're moving, and that they just don't attract each other toward each other because of their mass and the gravitation force between them. So can we explain that?
Okay, so that's a different scenario though. So when I talk about the ball and the earth interacting, they're two very, very different masses, so two very, very different accelerations. If you think about you're going along in a car, and you're going along in a car, and you have two balls, so they're essentially the same mass, very similar masses. And what you're saying is you don't see that the balls are attracting each other.
Yes.
That's because the gravitational force in general is very, very weak compared to other forces that you may ordinarily see. Just to be clear, right now, you're sitting next to each other. There's a gravitational pull between you and your neighbor, and between you and everybody else. There's a gravitational pull between you and the chair, and you and everything that's in the room. There's a gravitational pull, but it is so very, very, very weak that we normally don't notice it. That's true, but that's because there's similar masses, and the gravitational pull is very weak compared to any other force that we're experiencing.
That andagi di kapsi bana tiyang 비춘데 단다 저런 그 주화되게 비춘데 양고 현실당 저에 바kan실에 니타만도 지르샤스 남정 아주 그 볼로지 사강라 사그레스 담발라요 코로나기 바로게 다지 뒤세계 챕터 하천 전부 쇼지요로 뜨거 연구가 수사가 바 동교였다 탱교요 봤어 저게 있나 탱교요레스 탱교요다 임바이나야 뉴보 니기다 뉴보 총총 니기다 볼로 니바나 뉴보 니가 바로게 텐슈데 텐슈티 현다게 다시 들어봐야나 하천 총총레스 딘스담발라야 가속에 그런 파츠 대기 슈트는 논던트요 말레스 아테난신게 단다 진단나 따바인바나야 그 텐슈 요레 다 저런다 아니 전종 현다가 바로라야 뒤치징기 유보 인전 텐슈 요레스네 요레스 임바나 탱기요 말레스 진짜까지 라바이나 적당 전에 텐슈데 아니 슈체데 하장 다 총총 주요성 아니 파츠 텐트요 말레스 임바나 양 유보 바로라야 텐슈데 요 말레스 Yes.
We only notice the Earth's gravity because the mass of the Earth is so big.
Tenga zu duna chi gwa de ga la na skola ge tenshu ti shu chen bu yo ba de zu kar shi la tane re se na skola ge de che de ha chan chen bu yo ro wa o te la tane de da skola ge tenshu de ma su chor tu ba de la tane jung go res.
Well, let me show you something that is astonishing. So here I have a little bit of sticky tape, and it's sticking to this eraser in my hand. So it's sticking to the eraser because there's an interaction between the tape and the eraser, and that interaction is actually an electrical force.
Ta tandangi te la ya lapanana chi statica la ngi lapanana jasho yo ra nga su sticky sigdo wa jasho chi che ani te ga gang la ya ani nga su sabta yo wa shani ga chna sibya ga sabta yo te chi ga dos jasha yo is ta koran ta da dos koran jer da yo is ta jer yo pa te ga koran ni ge chi jaya ge ani shu chi yo ro te ta da de samno ka ga samna tang ko res na jaya te ani nga su look the shoe or look shoe la tango is.
Now think about this. The Earth is pulling down. The entire planet Earth is pulling down on this little eraser here. But the eraser is not falling. So the tape is applying a force to the eraser that is exactly the same strength as the entire Earth's gravitational pull.
Hanta tanda de ka simbana nge lapa ge ta ko jasho gang la ya ani sabta chi jasha ju de ro dus ta ko de de yo res tanda de ka simbana sabta de ge gang la ya ni skola ge ta skola cha chang wi ge tenshu chi ma teng de yo res ani de na shin ge de le do ba chi ani tanda ge jasho de ge ya sabta de ya teng ge yo res.
Yeah. So that was a bad experiment, but anyway, this is not the best tape, but think about it. The tape is applying exactly the same force as the entire planet Earth, this tiny little piece of tape. So that's how much stronger electrical forces are than gravity.
Ta tanda ngi la pa la yo pe ge jasho chon chon de ge ani tanda ge sabta de ga pho pe ge shu ta ani skola yonzo ke jasho tanda ge sabta de ga pho pe ge shu ni cha chung ge yo res ta tanda de ge ne tanda la ta ba ina ani ka su gre sta tanda ge jasho de la de tan khora ni ge sabta ni ge paru ge shu de de yin so sang tang ge lok shu yin so so de sta ba la ya de na no chi ko lok shu de ta ani skola yong ta tenshu ni cha chi pa cha yo res chi chong.
Yeah. So gravity is a very weak force.
This number ya tenshu se de shu che ha chang chu ji res.
Any other questions?
Nye George te choje. Ne tanda Newton ge tentem sumba kapso ane ngoboji lab ane shukji pogora shukji podo sumba kodang ane shukche nyambe kajo dobe shukji yore segora. Penadi karso tangjo gymnastics second in your again. Some second gymnastics. The Denzo Kunzo Kasa Ya Chong the Zugo Alok Tamakashi kept to win in the Euro.
Re.
The Denzo la karso Kugi Sai Golan and didn't Yambe Shukji Ya Kagir Sevore Carre. The Gisi and Karsa the gymnastics taking meted and Doce Yambe and Karso Ubuchi that Dodoji Yugne that didn't and Shuk Yambaji and Segolato Sagan like Shubaina and Dinanjinji and Yapartur to Mares.
The question is regarding the third law of motion, Newton's third law of motion. For gymnasts, you see that some of the gymnasts they just jump up and he can flip in the air for several times. So in that time, can we say that the earth is pushing him with that force that allows him to flip in the air for several times? So with that question, if we just throw a rock or some other thing with this similar mass on the ground, will that mass jump up as the gymnast?
Well, no. And the reason why the gymnast can jump up is because he's pushing down on the ground with his legs. And so the ground pushes him back up. It's the ground that is pushing him back up so that he can do all the flips and everything. The rock will just sit there because it's not pushing hard enough down. It's pushing just enough to compensate for the force of gravity. The push from the ground is always the same strength as the push on the ground. That's Newton's third law. So if I just stand on the ground, then the force that I'm applying on the ground is the same as the Earth's gravitational force on me. It's not bigger than that. So I will just stand there and not have any upward acceleration. But if I push down on the ground, deliberately push down on the ground with a force that is bigger than the Earth's gravity on me, then the ground will push back with the same force, which will be bigger than the gravitational force on me, and therefore I will have a net upward force, which makes me accelerate upwards.
Now, also his question about that rock or ball or whatever it is like if we throw the ball or the rock down on the ground.
Oh yeah, if you throw it down.
Yeah.
Okay, then yes, you can at the time when the ball actually is in contact with the ground, then the ball again is pushing with a force greater than the Earth's gravitational pull, and so the ground reacts back by pushing it with a stronger force, and therefore the ball flies upwards.
Tandani banaro because Nitani caps Chona Chongoreta, Cochipachi Pagoda Yomata, discuss Chona Chongore, Tandangatsu, that you lucidity in Banacoma, Chombi caps, March on that March, you up Sagan, Bejatan, the Tayan Quartaco, Kura Capjago, Jago, Watikalana, Ku man couldn't Bejatan shoot it, or Kuga Ma, Bejatan shoot it, Sukula get tenshul hot, Sukula get tenshul hot, Jago. 스콜라기 텐시도 집어치는 잡아야만 고마 텐데그라마 거야 포트도 말와 스콜라기 텐시를 하지 제가요던 스콜라기 양 버저다게 슈데 네 스콜라기 텐슈레 게와 모아요던 네 코야 파데데 놓고 딱 고라자고요 파나 그런 거 가르치고 파나 주지야 고갑라고요 됐어 이 나신게 당가 수 도당테로 유바인 바이나야 그 스콜라기 카틀라야 아니 그 대저 종이 값스 대저 종이 값이 슈데 아니 스콜하게 텐슈기 슈리 치워요 바인바이나 아니 딱 그거 마음 비자도하나지 스콜하게 야양 비자시 치치바시 징거와 야 비자타게 슈체테 스콜하게 텐슈리 치워요 바이나 아니 도티야 야 파그레스 다 도임바나 카림반티야 야 파그레스
Okay, so what I would like to do now is I'd like to continue, and because I still have a few more things to talk about, but then we can take up any questions that remain at the end.
다 단단하라 양 내동 가지 못지야 예스 게트 드라이어 바인바나 가츠라 양 디서 좀 바이나 톰슨 지금 저거 뭐라 치는 그래서
Yeah, so I want to talk about now about the very important concept of momentum.
다 단단히 구체세하게 데코드 시작이스
Yeah, so let me go back to the soccer ball and the elephant again. And to remind you of the situation, I'm applying exactly the same force to the ball and the elephant. Same magnitude force, same strength of the force. And yet the acceleration, the change in velocity is very different. And it depends on the mass of each object.
다 단단하죠 구체코드 시작이스 단단딩하죠 계산 뭐만 시작하기 비천티 양식 키운 바이나 슈슈 빠지자고레스 볼로다 란첸강라야 슈슈 빠지자고레스 임바이나 코 강라야 태비기다 뉴런스고로 왔디 만다오레스 다 되게니 단단 시작이스
Yeah, so now that's because the acceleration is the change in velocity. But if we have, if we think of a new quantity that combines the mass with the velocity, then the force will have this, the same force will produce the same change in this quantity, both for the ball and the elephant.
단단한 수가 뉴런스 비값이 뉴런티 뉴체긴 줄어와 단단히 값은 가지고 뉴체다 대체니처럼 뉴체다 대체니처 냠때 다 드위게 아니 지금 가서 퍼센트 which is to by 바이나 다 대값이 대체다 뉴체니가 줄바인바나 가서라 대 구체세 대라고요와 다 인스탄발라야 구체세 대다 슈세 대가레스는 구체기 줄어라고요 인스탄발라야 내가 지금 슈치파치 잡아인바이나 아니 가서 그래다 슈치파치 잡아 들라텐데 내가 속에 구체긴 줄 알고 그러는데 슈치파치 증거요레스
This combination of mass and velocity is called the momentum.
단다 되게 다 좋아서 그러다 대체다 뉴체다 되게 다 드니 잡아들라야 구체세 그래스
Technically, you multiply together the mass and the velocity of an object.
that is by bana de kapsa giati karchigorese resetan nyutse jurguyores.
So in terms of momentum, Newton's second law is much simpler. Newton's second law simply says that the force on an object equals the change in its momentum over time.
다 대양코 뉴턴의 텐션 이박나라야 대시자 바이나로와 네 갈치그레스나 슈크세치고라 뉴턴 텐션 이박 슈티로와 슈티 관계도 송그레스나 아니 구체적인 줄알던 송그레스.
So when I apply the same force to the soccer ball and to the elephant, you'll notice that before I apply the force, the momentum of the soccer ball is 0 because its velocity is 0. The momentum of the elephant is 0 because its velocity is 0.
당에 대강라와 볼로당 란친이 강라야 슈티 막 저게 뇌라야 아니 볼로당 란친 샤게 대가사 그체 레코레스 카실라 바이나 쿠란이 이게 뉴세테 레코렌자 그체 레코레스.
So as I apply the same force to both of them, the change in their momentum is exactly the same.
당이 대강라야 슈치바 치찬치 테바이나 네 쿠란이 샤기 그체게 지라데 치바 치찬레스.
The change in the velocity alone is very different, but the change in momentum, mass times velocity, is the same.
네 값을 쿠란이기 뉴체긴 지라치고와 뉴체긴 지라데 더요 말이스와 임바이나 양 그체긴 지라데 치바레스 데세당 뉴체 지르기 주테데 치바차기 그레스.
Yeah, okay. So just to give you a couple of very simple examples of that, if I tell you that this very massive truck and this tiny little car are traveling exactly with the same velocity, so the same speed in particular, which of these two do you think has the greater momentum? I'll give you a few seconds to think about that.
다다게 다 좋아지 유스와티 랑코르테니가와 랑콘데니가 뉴체치 총거 보낸 것이시기요 레스와 지데 트럭 챔버치르도 지 젠다데 랑코 총총치르도가 에스탄발라야 쿠가 뉴체치 바가네 조고요 바이나 네 강기기 무세테 치와요 사레스 텔라야 삼나다로 치스.
Okay, so the answer is that if they're both moving with the same velocity, and remember that momentum is mass times velocity, so the truck obviously has the greater momentum. So even though they're moving at the same speed, they're moving at the same rate, the bigger mass has more momentum than the other one.
다다데 값에 그 가르쳐버리세나 코란이샤 뉴세 치바치게 가는 로고 옆에나 양 구체세데 뉴세데 데세게 주고요자 아니 데라야 트럭 데라야 아니 데세 치와요자 아니 거기 구체데 치와요레스 데 값에 거기다 가서버리다 뉴세데 치바치창고 드지 치야게 세데 치바치창 임바이나야 데세 치와라테네 데데 구체 치와요레스.
So slightly similar but different question. Both of these vehicles have the same momentum, and remember, momentum has the same direction as velocity. So to say the same momentum means that they're both moving in the same direction. Now, if both of these vehicles have the same momentum, which one is moving more slowly?
다단다 되게 구와 도서치란 바인바나 가수게 구체세야 되는 거 구체라양 디오레스 카쇼랑 구체게 카쇼되는 거 구체 카쇼된 뉴세 카쇼 시바차기오레스 다 게디 다 데레양 거 드와틀란 드와테스 시탄 바이나 랑콘데 니차겐 구체 시바치장 요레스와 구체 총구요레스 구체 총구요 바이나 아니 데나네 랑코 강게치 타코 데보 간에 두고요 사레스. Yes, the bigger one.
Yeah, that's right. The bigger one is moving more slowly because it has more mass, so it has to be moving more slowly. Okay, very good.
치와데 대와 두고요. 에스카실라 바이나 고긴 구체 총구 유회장 아니 콜라야 고체 총구 요리스 거리스 다 뒤세 치오에 스탄발라야 아니 요체 총아 요리스.
Yeah, so just to recap, again, Newton's second law says that the acceleration, which is the change in velocity with time, is equal to the force per unit mass on the object.
당가 수제 줄지 바이마나 뉴턴게 템페 니바가 가스 그래서나 뉴보식 뉴너스 그런 뉴보식 뉴너스한테 그게 뒤기 조트라야 뉴스긴 조트라 뉴스긴 조트에 뉴넌데 관계도 성그래서나 뉴보되게 되서레라 포피기 시간 총세 그래서.
So if we know how much force we're applying on an object, and separately we know the mass of the object, then we can tell by how much its velocity will change from one moment of time to another.
딱 getting out so 뉴보식 강라 포피기 슈하고다 되네 아니 그게 디세티 하고요 바이바나 아니 가속에 그 가서 그래 뉴보되게 아니 뉴책인 지로아티 가서 임바티 하고 그래서.
So if we think in terms of momentum, Newton's second law is saying, well, the change in the momentum with time is equal to the force acting on it.
다 뉴턴 같은 뉴와테 삼나당 바이마나 그래서나 뉴보치긴 고체긴 지로아티 아니 뉴보되게 강라 포피게 슈던 총그래서 그래서.
So if we know the force that is acting on an object, we know right away by how much its momentum will change from one.
딱 뉴보되게 강라야 포피게 슈디하고 엠바나 가서 뉴보되게 아니 그 고체긴 지로아치고라티 람상하고 그래서.
But I think that we've already talked about this. So, so with all of this in mind, let me now turn to another type of force that that is very frequent and that we can say something about.
다 때네 양아수 슈 현대적 거래 시작이 인스타티 그 지금 남진 같은 통대와 지금 레스.
And these are impact forces. These are forces that happen when two things collide.
다들라야 답시세 그래스. 다 답이슈 답시세데 갈라나 뉴본이 동태적 값이 좀 그래스.
An impact force is usually very brief.
다다게 동 답시치오로 답시때 그 정하때 대연 하전 통통 값이 좀 그래스.
It only happens when things actually are touching.
네 같은 좀 그래서는 동요스 뉴본이 판스 투비 값을 거는 좀 그래스.
If you think about, for example, a ball that is falling to the ground and it actually strikes the ground, hits the ground.
다 볼로지 살강라야 사바제 볼로티 동요스다 살강라야 포비 살라야 투비스고라 살강라야 다비가 값텔라야 상마당 그래스.
So the impact itself, the process is very, very brief. And it starts when the ball just touches the ground, just touches the ground.
단다게 답시세야데 그 종약이 뒤임때 하전 통통레스. 그 같은 거죠 그래서나 또 볼로말 홍바데 살라야 투비와 살라 당부 투비니까 되는 거죠 그래서.
Now, the ball obviously is moving and has a non-zero velocity downwards at the very beginning of this. But then throughout the impact, which is very, very short, the ball will squeeze down, the ground will bend a little bit. And so the net result is that the ball comes to a stop.
단다데 가서 그 퉁놈이 제라야 볼로데게 그 살라 투지레데 아니 그 당보 뉴스치거나 마 연구요라 뉴스치거나 용데다 사강라마 괜찮다마 사강마 낸데티 타마기다 다 디버스나 듬디데 칼레스나 그 데치기요레스 당고 참 조크레스.
So let's just think what's happening during that very brief time interval between when the ball just touches the ground and is moving downwards until it comes to a full stop. Initially, the ball has a certain downward momentum.
Hanta tanda de kapsa nga su nikap tela ya kare chungu yomegi nitande tag insta tambo tela ya polo ma yon sta pala ya ko kama shopi gen gutsechi yoro asta tanda de kapsa ko da polo te sangwela thyoba da thyoba kapsa ko ma yon goro kula ya nyutsechi goro gutsechi goro dene ne polo te chamshaga goro ko gunsam juga goro o te ge nikap tela ya kare chungu yometagi ins.
Remember, the momentum is just mass times velocity. So in terms of direction, the direction of the momentum is always the same as the direction of the velocity.
Tanda de kas gutse seati ani gutse seati nyut ka desete nyutse ge jubu yorwa tin stambala ya de kapse gutse ge khasu de katim baina ya nyutse ge khasu to chipa imba de ngi gures.
So if at the beginning it has a downward momentum and at the end it has zero momentum because its velocity is zero, the change in momentum has in the upward direction.
Da tampo de la rota ko ma tampo phobi kapse sugora ta tampo tubi kapse khola ya gutse kama shopping gutse chi yorwa ani thama de la ya ani ko den gumete ni bi kapse imbaina de kapse gutse lekorwa tin stambala ya the tige paro tela ya ko ta maprach kale ko chaga cheto ane ko ge thamage das gore tang guseti ne kha ya shopping gusechi gu yores.
So that change in momentum over the very short time that it happened, that is equal to the upward force by the ground on the ball.
Ta tanda ge chi tikap ha chong thong thong tige nang la ya ane ma yo pi gi karsugre gutseni gutse lekor chhaegi gutsegin jurachi yorwa gutsegin jurati te karitan songre sena sagi polute gan la ya popigi shuton songre yores.
So the strength of the force, remember, according to Newton's second law, the force is equal to the change in momentum over the time. If the impact is very, very short, the force is very big because it's the change in momentum has happened over a very short time.
Ta tanda de kapse shute rota Newton de kapse shute ani ta digin jurag trailer digin jurag trailer ya ani karsugre gutsegi jura la ya gugu yores ta tin stambala ya ani de kapse ro kete ani ko ta dontri jara ta yana digi duin te ha chon tonton imbaina ha chon tonton imbaina ani kasam gutselan juran ruge duin te ha chon tonton imbaina ani shukti chambo yores.
That's why impacts are very often destructive because you're applying a very strong force during a brief period of time. Force is very big.
That is tambala yang asu dong tija ba tela tene de ko karsubasana tigita nochun zut kuyore nochun zugo yore swa nochun chen resta de junsen kalchila baina choronge ta 뒤에 하정 통통치는 라야 슉슉 참고치기다 포바치기 여러 때 때니 아니 동투디 내고 너춘 그런 전에스.
So if we think about I'm not sure what happened here, but if we think about this rectangle here, where the height of the rectangle is a measure of the strength of the force, and the width of the rectangle is a measure of the time during which you apply the force. Then the area of the rectangle represents the change in momentum.
Jontik ganlaya shukchi chonche and the tetik ganlaya doing gasoju ngomregi nitanti baina nitanda gi tushin narmo de jachun tiki kare chongres na ane ko shuti popi doing tinala juachim bigin gutsegi juate chongres.
So in an actual impact, there's nothing you can do about the change in momentum. The incoming velocity is a given. The final velocity by definition is 0. So, and the mass of the object is given. So the change in momentum is given. The only thing that we have control over is how long it takes.
That dabshik kapsing aso de kapsa ta ko ngibuji popi kapsin bana ta tampo ko yombi kapsa ko la nyurse chigore tamang nyurse de leko chagoro atis tabalang asuge gutsegin jirwa chigore ta ko gutsegin jirwa te tenkeres tampone haku yores ta tingi bares ta de kapsing asuge ta ko ge shukchenti ya ma la ya chiga karsogore ta jura tanga chitanga su karichia yores na ku popi gi twin jiro yunse te ne ko irin te nyana thond tanga gi tichia yores.
So if I want to reduce the force of the impact, what I can do is to stretch it out over a long time.
Tangi shuti la tembi gi shuchenti ta nyont tangu yo pa na shuti popi gi twin te rant tanga yores.
So if I make that rectangle longer in the time direction, but the change in momentum is the same as before, then the force amount is much smaller.
Tanda di ngamge ko twin ti rin de tang bai na de kapsro de kapsa ta ngutsegin jirwa yo ro ngutsegin jirwa te gang de ta wotin chi pares imba ko ge shupha chora shiki shuchinte ani nyont do res.
Yeah, so this is a very practical application of Newton's second law. We do have, occasions when someone is subject to a big impact force, an impact, and we want to make that force as small as possible to reduce the damage. So the trick is always the same. Try and make the impact last as long as possible.
Ta de gara na Newton ge tanti ni ba ge pecho gi ta arrangin cha go res ta nga so la ngi bu chi ta chi da ba imba na ngi bu chi ta dong the ja go ba na ani ti shu ti gi shu chen ti jinyon ta ya la ya ni nga su shu ti phopi ge tin de ran ta tang go res.
Okay, so let me give you a couple of examples. First of all, catching a cricket ball, and this is a personal favorite of mine because when I was young, I grew up in England, and we played cricket at school.
Tanda de nga su ge extepolo ge lo yu pe chin zimbe ge ani pe chen chi hin so nga ani chin chin be kapsa lopran do kapsa nga de extepolo de sigi yes.
And I hated playing cricket because the ball is very, very hard, as you probably know if you've played.
Tanga te tsela shu go me skajla baina polo te ani hachang kasgreta jikoso the chabu yores.
And, so if I was fielding and I had this very hard ball coming towards me, the last thing I want to do is put my hands in the way.
You were cut off. Can you repeat that again?
So if I see a cricket ball coming towards me, I don't want to put my hands in front of it.
Ta polo chingai shola yongo yo bai na ngara bai na ni lakpa tin den wan dos ta polo ja chete jonye chugum dos.
Nobody taught me this. Nobody taught me how to catch a cricket ball.
De kashla bai na ngala ya ni kasa polo te juwi gi jetap te and lama sons.
Yeah, so the way to not hurt your hand is to go with the cricket ball as it's coming towards you and actually move, stretch out the impact in time.
Ta ngone ko njistante karesana polo ta ise polo te sus chola yon bekas polo te lakpana lepa che ani polo ta nyam to ro ta polo te lakpana tele ta popi shuchin de jinyo to ai che to polo to nyam to ne ko kasugre da this the popi din de rand ta de ta boilu ge shola ya la pa de met to strugu yores.
So same change in momentum. The initial momentum of the ball is a given. The final momentum of the ball is 0. So same change in momentum, but I make it last over a longer time, smaller force.
Ta dan de kapse ko ge gutsegen jirwa de sikpa sikchang res gutsegen jirwa de wa bolo de ge ta tampu nga su la pa na po kapse ko la ya gutse jiwa ne thama de la ya gutse le ko cha gu yo wa ko ni che le ko cha gu yo wa gutsegen jirwa de sikpa sikchang res yimba na ya shuki shukchen de nyond ta ge che to ane ko shu ta bolo de ju so shu de popi ge din de rand ta yes.
Here's another example, and this is the reason why if you ride a motorcycle, you should always wear a helmet.
Tadi pisun shenda chires, ta pisun shenda chikara cho ti baba jombi kapsa katyen na ya baba ka makshadi kongu res.
Motorcycle helmets are big usually, and the reason why they're big is here's a helmet that's been cut in half so we can see inside. They have this big layer of styrofoam, which is a soft material that squeezes easily.
Ta de nga chuge baba ka makshadi ko thoya gi chet tumba nila ta sha ji tena res ta de la ta ba na paro de la ane ko karpuch to ga de ko de nga chuge ta jig sopso chi yo sopso o de gi tripsha ju res.
So if you happen to fall off your motorcycle and you're unlucky enough to hit your helmet, to hit your head on the pavement, that could be, that could kill you because it's a big change in momentum over a very, very short time.
Da ke ti chorang ge baba ke shamu de mosade ko me ba na ke ti chorang ne chi gender trap je sala sa ba na ani chorang go ti lamkha kan la da ba na ana ti pe ti ge chorang chi china soche de chong ge skar chi la ba na ti kaps ta gutse ge jura chi tu yo ro gutse ge jura de ge shuchen de ha din ha jong tong tong chi na de ko yo res.
So if you're wearing a helmet, then you hit the pavement and that will more gradually squeeze the soft material inside the helmet so that the impact takes a much longer time.
Ta ke ti chorang ge shamu de ko yo pa na sala da pick up sala da pick up ani paro ge sop ti sta zurui ge tin chi yo ro zurui ge tin de ye zang ani gola ya chi double aten de ta shuchen de pa ge tin de this rant tang yo res.
Same change in momentum, longer time, smaller force.
Ta de kapsen gutse ge jira chi chong res. Ana tin this rang wang go yo zang ani de la ya shuki phoya ge shuchen chwa yo res.
The last example I will give is also has to do with traffic, and that is wearing a seatbelt in a car. Always wear a seatbelt in a car.
Ta pisan shenda chi kare se stambala muta na ne dro kapsa ka tu imba na ya nga su nyen sung ka kala chi ro ti chang gu yo res.
This is if you collide with something in your car, and you say you have a frontal collision. This is an interesting example again of an accelerated reference frame. If your reference frame is in the car, you're riding in the car, and all of a sudden the car hits something, and the car decelerates. Your reference frame has an acceleration. You will keep going, and relative to the car, you will have this forward acceleration.
Ta muta na dro we kapsi imba na ro muta na dro de ten dro imba na ke te muta ge ta nyunon thep chi dro yo pa na ani ta ke te chung muta ge ta muta ge chila dong ba imba na muta dong la muta chi ta ga garwa imba na ya chorang la ya ki ge nyunon chin dro yo zang chorang ta denlo dro ge chi kar so re te
Yeah, it's like the ball in the train, but much, much faster.
Tate nga suge minkona na puluchi badate dwechi yo tetan songo yore simbana nikap tanda kapte la ya hachan jokpo gonna do this.
If you're not wearing a seatbelt, you will continue forward. You will hit some part of the car, or sometimes people go straight through the windshield.
Ta tanda ge nyeson karate machang pa bana chila da pickups ane cham la ya bana ko kasure ji muta dongti ja pickups ane muta ge danlog la yo pe chashi tu la dongya dong cham la ya ni karate machang la tene ta mi khashi te pete muta ge nani pete chlo yuya ge ane tong kinda chong grace.
Not good. But if you're wearing a seatbelt, what the seatbelt does is it stretches a bit. And in stretching, it will still make you stop, but it's stretching the impact over a longer time.
Tanda karate, nyason karate champa imbana yagoris, putis a nergaris, tia nerbala tenedeti karchigresena, koranga shuchinto poyagi duindi this ramp tanguris.
You will still feel a force, but it's much smaller because same change in momentum, longer time, smaller force.
Ta shuti poya karsugresna, gutsegi nubati, gutsegi jurati chiparis, imbana ya, koge duindi sugata, the poyagi duindi this ramwayota, and a shuti poyagi shuchinchura, shuti shuchinti nua pokores. Shupoya nuayores.
Impact forces are a nice example of Newton's second law expressed in terms of momentum.
Tandagi dabshik sayachigorwa, dabshik sayati, ane Newton ke tanti niba ke kapsa gutsegin jwa la tani de kichishi be kapsa pitsin yapuchi res.
Because that's what Newton's second law says. Any force that is applied on an object is equal to the change in the object's momentum over time.
Ta tanda de kapsa karsa goresena, ane Nubachi gala popegi shooterwa doing ichenchkana la ya, ane nubo taking gusela ya, chimbigin jurata tsongurela gores.
Okay, and now I want to finally talk about one more thing. I want to say one more thing about momentum. And again, I will use the same example as a collision between two objects. But this time, let's think about two objects that are roughly of the same mass. So in a collision, the velocities of the objects will change. The impact will be brief, but at the end, they will come up with different velocities than they had to begin with. So what will happen is, because their velocities change, then the momentum also changes. So the momentum of each one changes. And this is because while they're still in contact, while the collision is going on, each one is applying a force on the other. Now, Newton's third law says those two forces are equal in strength and acting in opposite directions.
Newton ke tension sambata na koranye dongkha jashin bigini kaptela pensin dombi shu insha ane chichong songwa tang khasho doyo resigres.
So the change in momentum of the two objects it's also the same and in opposite directions.
다 되게 값은 구체적인 주로한테 양코 가서 그래. 구체적인 주로한테 양총 받아 아니 가셔도 돼요. 그래서
So the total momentum, if I add the momentum of the two objects, the total change in momentum is zero.
다 되게 값을 이번 이차기 아니 가서 그래. 구체적인 주로라 따바인바나 구체적인 주로한테 라이퍼차 그래서.
So even though they come off with different momenta, the change, the total change of both of them is zero. So that means that the total momentum of the two objects is the same after the collision as it was before the collision.
다 그런 이제 동태 잡는 게 제라야 군샤라야 구체 만로 여바이나야 아니 단다기 차청아서 구체기 주로와 차이 용수 조바텔라야 아니 저러고 말이스 스탄발라야 디캅스 카리스고레세나 뉴포니기 동태 마제 원기 구체다 아니 동태 잡는 게 지금 구체 아니 차송고레스 지파레스.
So the terminology is that the momentum of the pair of objects is conserved. It's the same after the collision as it was before.
this tabala kugan gutsete nyatsa chirese gres tekarda bana nyubun don't maje ngi gutsegi chandam te ta ani don't jamdu gi gutsegi chandam te chiparese gres.
So in an isolated system of objects, so if you consider here we're just thinking about two objects, but you could have more, all of them interacting with each other, but they're not interacting with anything else in their surroundings. However complicated those interactions may be, the total momentum of the system stays the same.
결정했던 배경이 본인이라고 지라 삼는 당방인 바이나로와 그 출력의 현다다 대저 지금에 봤지 니 코란 차기다 코란 차고 바로라야다 대저 간다로 지청고요 바이나 투여동 투자라기네 단 간다로 지금고요 바이나야 말라다 록스컬 배경이 본이 트백에 말라지고라다 말라대기 아니 그게 전동기 무쇠지고와 된 주라메 빙함이 그래서.
So this is a fundamental, very fundamental and very important law of nature, the conservation of momentum. If you have a system of interacting objects, and they will be interacting in very complicated ways, as long as they're not interacting with anything else outside, the total momentum of the system is conserved. This is called the principle of conservation of momentum.
단단하게 값을 일부 지금 말라 지나나 요비기 일부 지스가다 일부 구조 바라라 대조 가나로 지기 요바이나야 철로다 대조 지금 맵이 값을 근데 말라 뛰나나 요비기 일부 대게 아니 일부 대딱 대조라 템비기 구세테 녀서 지그레스 그레스탄 데라야 아니 구세 녀석게 전진이 너가 어떻게 그레스.
Chad will later on talk about another very important concept, which is the concept of energy, and there will be a principle of conservation of energy there as well that he will talk about.
Again, Chad lagi tadan detan ta dewa yuju sukuro ta ngasu nyuba nyersok ke tanzin chiwaro ati for jela again Chad lagi deshan grace.
And so I just want to note finally that this idea that the total momentum is conserved comes directly from a symmetry. A symmetry is something that looks the same. So Newton's third law, for example, is a good example of this. Newton's third law says if you have two interacting objects, the force that they apply to each other are exactly the same strength, they're just in opposite directions. This is a symmetry, and it is this symmetry that gives rise to the principle of conservation of momentum.
단다게 ngasun gusen yersak tanzin chiwaro gusen yersak ke tanzin de ane namchung gi rangin chila tani chungyo resta namchung rangin de tanda neutron ke tantin simba yora neutron tantin simba ge kharchi warsane Mubo Niga Parola, ya, Dejuchi, Pane, Shuti, Chichonchi Pache, Kasho, Doxagor, the number Chongi Mutigane, and Deshijaboris. That Tandagi, Nam Chongal, Nanjin de Latinity, Tandangasungu Senior Substances and the Latini Chongaris.
And I'm sorry we don't have more time to discuss this. This is a very important topic, but I just wanted to leave the idea there that at the most fundamental level, what we perceive as laws of nature are really expressions of symmetries in the world.
Tatanda Masulaya Deokola Trader Tajucha Komba, a Jonas Mosimbanata, Matsu Arangshun Kamla, your pig in Kamgi, Chupuga, number Tanang Tsigi, Jitsagi, Stanzindo, which were what is just, Shishasate, Nengatsu, Jitsaga, a Namson Ranges, Gorata, number 2 symmetry, Namson Ranging Ola, Shishaji, watching those.
Okay, I'm afraid that we have almost run out of time, and we won't be able to take any more questions, which I regret because I really enjoy your questions. But I just want to say how much I have enjoyed being with you these last couple of days. I want to thank you for your attention and your enthusiasm, and I wish you all the very best. Stay safe, stay healthy, and good luck in everything you do. Thank you so much.
That Nanga so those and I take a lot and take a comment to and then Nimani Rangla, so something change to system Valaya, two shoe Johnsons, and Labat to draw down to Laya, a big old Johnsons. Netanda and Nishitsuge, and Trotan to non Chichi to Chishiro Chess, the Nanshan Nishitsuge, and a curry Changi Patizulaya, Chalam Duyon Vigi, Mandashigis, to chase.
Okay, thank you.